Hi, and welcome back to the third installment in our Mixing C++ and Rust series. Today, we'll start to integrate Qt into our application. This integration will be based on CXX-Qt, which is KDAB's extension to CXX that allows integration with Qt's meta object system. If you don't know CXX yet, check out the previous video in this series where I explained the basics of CXX. The link is in the description. As CXX-Qt is an extension to CXX, it's important to have a basic understanding of how CXX works. A basic understanding of Qt and QML will also be helpful if you want to follow along with this video. We'll link some resources to get started on this in the video description. Now, let's talk about Qt with Rust. Qt is one of the most powerful UI frameworks and a big part of the C++ ecosystem. It allows you to build beautiful user interfaces for desktop, embedded, and to an extent, mobile and web. As Qt itself is built in C++, a usual Qt application uses C++ code for the backend of the user interface. With the CXX-Qt library, we can instead use Rust for our backend and even integrate with existing C++ backends. In a Qt application, the frontend can be either written in C++ with Qt's widgets or in Qt's new modeling language, which is called QML for short. With CXX-Qt, it's possible to manually interface to Qt widgets, but CXX-Qt is primarily written to support frontends in QML. QML allows us to write our user interfaces in a declarative way. In my opinion, this makes UI development far easier and faster compared to Qt widgets. With QML for the frontend and Rust in the backend, we can build a very modern UI that combines the ease of use of QML with the stability and safety of Rust. So, how does this work? Before we dive into coding, it's important to understand what CXX-Qt does and how it relates to CXX. CXX already enables you to interface with existing C++ code. If Qt was just a normal C++ library, this would be all we need. However, Qt actually extends C++ language with its meta object system, complete with a custom compiler and special syntax in the form of macros. This is what enables Qt's additional features like QObjects, properties, signals, slots, as well as the integration with QML. CXX does not support these features, as they are not standard C++. This is where CXX-Qt comes in. It fills this gap and adds support for the missing features while remaining compatible with CXX itself. Today, we'll build a simple application with CXX-Qt's newest version 0.7. This release marks a major milestone for CXX-Qt, as previously, most of the API was still in development and unstable. With version 0.7, much of the API has now become stable. So the CXX-Qt bridges in this and the next video will also be compatible with future versions of CXX-Qt. So let's dive in and build a QObject in Rust. Now what we see here is already the finished application. Just to show you where we want to go with this tutorial and what the resulting app should look like so that you kind of have an idea where we're going. We just have a simple window where we can select a greeting, so either hello world or bye, and we can also select one of 3 languages. When we then click this greet button, our console will write the correct greeting with the correct translation onto our terminal. And as we can see here, this is all happening through QML. So this is really where we want to go. And where we start is actually with the previous result of our CXX basics tutorial. And that means we can simply, first of all, copy our existing project into a new folder and expand on that. Now that we've set up a new project, we also need to change this project's cargo toml to use CXX-Qt instead of just CXX. I'll also rename the project so that it's actually called CXX-Qt Basics, as we're no longer just going over CXX in this video. As dependencies, there are 3 main things to keep in mind. We first of all need CXX-Qt itself, but then we'll also want to add CXX-Qt-lib. CXX-Qt-lib is in itself not an extension to CXX like CXX-Qt is, but it's a library of Qt types that are very, very helpful to be used in conjunction with CXX-Qt. In theory, you could use CXX-Qt-lib without using CXX-Qt yourself, though. And the third dependency that we'll need is a build dependency. We previously used CXX-build. Of course, this will need to be replaced with CXX-Qt-build. Here, you should just look up which version of CXX-Qt is currently the stable version. But what I will actually do is I will use the main CXX-Qt repository to give me the very latest changes. Though if you want to build a stable app, I would probably not recommend this, and you could, at the time of filming, use version 0.7 instead. One thing to keep in mind when adding CXX-Qt-lib is that with version 0.7 of CXX-Qt, CXX-Qt-lib now requires you to mention all the features that you want, specifically which Qt modules you want from CXX-Qt-lib. The easiest way to do this for this tutorial is to simply use the full feature, which will give us access to everything. However, if you're actually building an application, this could massively increase your compile time. So I highly recommend only adding the features that you really need. But for this tutorial, we'll just go with full. That's the simplest for now. So this is now our updated cargo toml. We have added CXX-Qt, we've added CXX-Qt-lib, and we've replaced CXX-build with CXX-Qt-build. So far, so simple. Another thing to note is that we still need CXX as a dependency. This is due to some of the way that CXX-Qt expands the macros. And for now, this is just simply a requirement. Otherwise, you may get errors about CXX not being a dependency. And if that's the case, simply add CXX here. We can then go back into our main.rs file that we wrote in the previous video and change our CXX bridge to a CXX-Qt bridge, which will give us access to all the new features. So here, simply replace CXX bridge with CXX-Qt bridge. Adding CXX-Qt bridge now gives us access to all the additional features from CXX-Qt. One of the most important features of this is the ability to create so-called QObjects. These are basically C++ classes that have access to Qt's meta object system, so can be accessed through QML, for example. The way CXX-Qt allows us to write new QObjects is by wrapping an existing Rust struct type and creating a QObject class based on this. So for now, let's first create our Rust struct so that we have a basis on which we can build our QObject. Note that for this, we will actually go outside of the CXX-Qt bridge, as we can just declare a normal Rust struct. It doesn't have to be inside the bridge itself. Here, we'll call this struct greeter Rust. We'll want our final QObject to be called greeter, as that's the name that we have from QML. But because our final QObject is actually a different type than our internal Rust struct, we found that the convention of simply adding Rust for the internal Rust struct works quite nicely and makes it clear what is meant. So in our Rust struct, what we'll need in order to provide the greeting that you saw in the introduction is, first of all, of course, the greeting itself, but also the language that we want to use. Another point to note when using CXX-Qt is that it needs to be able to construct this Rust type in order to wrap it in a QObject. The easiest way to do this is to simply implement the default trait on your Rust struct. If you're coming from C++, this is somewhat equivalent to a default constructor. So we'll implement this here and provide some default values. So that's pretty much all you need here. You just provide some default values for your type and then return an instance of it. and CXX-Qt will automatically pick this up. There are also advanced features like the CXX-Qt constructor that you can use if you want to do more complicated construction, but this is usually the default that you want to use for QML. The next step is then to export our Rust struct as a QObject type using CXX-Qt. The basic premise of accessing CXX-Qt's features through the Rust bridge is by using what we call extern Rust Qt and extern C++ Qt blocks. So just like we had extern C++ and extern Rust in CXX, we now have extern Rust Qt and extern C++ Qt. Because we want to now expose a Rust type to C++, we'll need to use an extern Rust Qt block. The basis of creating a QObject with CXX-Qt is then to use the QObject attribute, which is very similar to the QObject macro that you might already know from C++. We will then create a new greeter type that, in this case, will replace the existing one that we wrote in C++. And the way we do this in CXX-Qt is to create a type alias, which in this case isn't really an alias, but it rather tells CXX-Qt, hey, this type here on the left should be created by wrapping the type on the right. And we express this again with the QObject macro. Of course, in our previous CXX example, we already created a greeter type in C++. We won't need this for this video, so we can get rid of this part of our CXX bridge. Additionally to simply creating the QObject type, we will also want to be able to, first of all, access the type itself from QML. And also, we will want to be able to access the language and the greeting from QML. The way Qt usually does this is through so-called properties. Properties are values that your UI can set, read, and also be notified about when they change. With CXX-Qt, implementing properties and also accessing your type from QML is actually very similar to how you would do it in C++. And there are two attributes for this. First of all, QML element, which is what allows us to access our type from QML. And second, the QProperty attribute. And the QProperty attribute in its simplest form just takes a type and a name. And that will tell CXX-Qt that we first of all want to create a property of set type and name. And by default, it will assume that the struct that is being wrapped already contains members of this type with this name. So it will automatically forward everything for you. It will create appropriate setters, getters, and even a notify signal. So in this case, this will take off a lot of the heavy lifting that you have to do in C++ manually. In this case, CXX-Qt will do it automatically. So now we have both of our types actually exposed as properties. And one thing we also need to do in this case is to expose the greeting type to C++ as well and to QML so that QML has access to the members of that type. So we've now changed our greeting type to live in our bridge, which means both sides of the bridge can access it as if it were a native type, except, like we said, for the small detail that an enum in CXX is not quite an enum in Rust, so we will need to ever so slightly tweak our access from Rust. And that's it for exporting our QProperties through a QObject into QML. It's as simple as that. Now that we've added our QObject type and have exposed it to QML, we can also start adding behavior to that type. Before we do that, I would first like to show you a convention that we really encourage with CXX-Qt, which is to rename your modules from what the CXX default of FFI is to QObject. The reason for this is that when you name your module QObject, you make it pretty obvious that usually you are referring to QObject types, which is what most often will be the case with CXX-Qt. And now that we've done that, that means that our greeter type, for example, will be accessible as QObject : greeter. And we will use this to now start implementing our first method, which we will call greet, which, well, as the name suggests, allows you to greet by returning a QString. For this, we go outside of our bridge, because that is where the actual implementations have to live. They can't live inside the bridge. The bridge is just for declaring that certain things should already exist and be exposed to the other side. So here we can simply use impl of QObject greeter and then start creating our function. In this case, we will want to return a QString, which is the default string type in Qt. It is actually different from both the Rust string and the C++ standard string. So that's something to keep in mind, that this is a separate type and you may have to convert between, for example, the Rust string and the QString. Also, we need to keep in mind that when we use CXX-Qt, we need to import the type from CXX-Qt-lib. As I said, CXX-Qt-lib includes kind of the most basic types that you will need in your default Qt application. So we can simply import the type from here. You can still use CXX-Qt without CXX-Qt-lib, but it will be much harder as most types just aren't available then. CXX-Qt is just simply meant as a layer on top of CXX, and all of the type wrapping and access to the Qt API can be done with CXX-Qt-lib. So now that we have started to implement a function, let's add some behavior to it. As I said, QString is a different type than a Rust string, but we can simply convert to it using the from trait by calling QString from and then providing a Rust string. In our case, we will simply want to access the translate method from our greeting. So there we'll just call self.greeting. What you should notice here is that the QObject greeter actually has access to our greeter Rust struct and its internal values, even though these are two distinct types. This is not magic, this is Rust's deref trait. It allows us to basically automatically dereference an outer type to an inner type, in our case, from our QObject to our internal Rust struct. This works at least for immutable access by default with CXX-Qt. If you want to make this explicit, what you're doing, you can use self.rust, which always gives you access to the internal Rust type in your QObject. For mutable access, this deref, for technical reasons, doesn't work automatically, so you will have to call rust mut, which is the mutable equivalent of the Rust function. But for immutable access, like here, where we just need to read the data and not modify it, we can simply use the deref trait to access everything directly. And that's it. We've simply created a QString from the translated greeting. Now, the next important step is to actually expose this function to C++ and QML. For this, we need to go back into our bridge. And inside a Rust Qt block, we can then tell C++ and by extension QML what is available on our QObject type. For this method, we will use the QInvokable attribute, which allows us to both expose the function to C++ and to QML. And by that way, it is actually just very, very similar to the QInvokable macro on the C++ side. So if you're used to what C++ does to talk to QML, this should feel right at home. And like with any other CXX-defined function, we will use the special self : and then the type syntax to declare that this function is implemented on our greeter type, and then it just returns a QString. However, now CXX tells us that this type is not supported, because CXX, and therefore also CXX-Qt, only has access to the types that are declared inside your bridge. We also need to tell CXX where this QString type is coming from. In this case, of course, QString is a C++ type, as it's implemented by the Qt framework. Therefore, we simply add a normal extern C++ block where we import our type. And the first step to do this is to tell C++ where to include the type from, and then to tell the bridge where this type is already bridged in CXX. Because this type is wrapped by CXX-Qt-lib, we will want to use the QString header that is provided by CXX-Qt-lib. With CXX-Qt-lib types, it's important that you always use the corresponding header in the CXX-Qt-lib crate, because those may include additional wrappers that should be included when using the wrapped version of that type. To then import the type from CXX-Qt-lib, what we'll simply do is write type QString equals CXX-Qt-lib QString. And this will tell CXX that this type already exists and is implemented in CXX-Qt-lib. And now we are able to save our file and not have any errors inside the bridge itself. There's one last step though that we need to take before we're ready to start our GUI. And that is to allow QML to interact with our enums. Because these are declared inside the bridge, they're actually already exposed to C++, but that doesn't automatically mean that they will end up in QML as well. For that, Qt also, again, has a special syntax and a special macro, which, like the QObject macro for object types, is in this case the QEnum macro. And of course, CXX-Qt supports this as well. So we simply add the QEnum attribute to our enum, and then we tell our QEnum on which QObject it should live on. This is a bit of a peculiarity about QEnums, is that they always must be defined either within a namespace or on a QObject, and must then be accessed through that QObject itself. So QML, in this case, for example, will need to access the language English by writing greeter.english. And the same goes, of course, for our greeting, which we'll also expose through our greeter type. We could also expose these enums through namespaces, but for that we will also need the special Q namespace macro, which we won't go into depth here, but this is of course all documented in the CXX-Qt documentation. And with that, we are finally able to start writing our GUI in QML. To create our QML GUI, of course, we first need a QML file. For this, I'll just create a new folder named QML, who would have guessed, and let's add a main.qml file. Inside this file, I'll first get some standard imports out of the way, so let me just quickly add those. So as you can see here, we basically have two categories of imports. First, the ones coming from Qt Quick. Those are just default modules provided by Qt that provide us with default types like a window or buttons or labels, that sort of thing. Our second import here is to our very own QML module. We will go over how exactly this is defined and where the name comes from when we get to building our app, but for now we'll just assume that this already exists. We can then go ahead and instantiate a window so that we have some window to add functionality to. In Qt, this is done with the application window. And here we can already see how easy it is to create certain behaviors with QML. We simply add the type we want and then tell it what certain of its properties should be. And QML will just take care, or Qt rather, will just take care of creating that application window for us, setting it up with the right width, with the right height, making it visible, and once we start adding subcomponents, QML will automatically add these to the window, lay them out in the right way, and this is just a far more declarative way of writing what your UI should look like and not how it is constructed, because we don't necessarily care that much about how this works, but rather that the result of that, of how our UI should look like. So the first thing we'll need is our greeter type. We've declared it as a QML element, as we can see here, and that means within our com.kdab.tutorial module, we can access it by its name, which of course is greeter. And this way we automatically instantiate the greeter, and we will, in this case, automatically use the default trait to get a default constructed greeter that we can then assign, for example, properties to, or in our case, assign an ID to, which is QML's way of saying this is a variable of a certain name. So in this case, we'll also name our greeter, of course, so that this is necessary so we can refer to it later. And this is just how QML allows you to refer to certain objects. Then we will start adding a row layout, which will make sure to lay out everything we add in here as a row, so one next to the other. And first of all, we can make sure that this actually fills the whole window, because there's not really anything else that we want to add to this window at this point. Within this row layout, we then want to add what you saw in the original demo of the application. So we want to add a label for our greeting, an actual combo box to select the greeting, and the same for the language, and then an additional button that allows us to actually greet our users. So we'll start with adding a label. And then our combo box. So what I've added here is just a combo box that, first of all, has a role for the text and a role for its value. So meaning the text is different from what will actually be selected, because what we want to be the actual value is our QEnum type, and our text is simply a translated text of, for example, hello world and bye in this case. And the way we set this up is to have our model be a list of objects where the names of the keys in this object reflect the names we've chosen for our roles. We will then also tell the combo box that when it activates, meaning when the user selects a value from the combo box, that it should tell our greeter to assign the greeting to the current value of the combo box. When we boot up this application for the first time, we also want the component.onCompleted call to then set the index of the combo box to the value that's already in the greeter. That way we just assure that whatever we assign as the default in Rust, we will get that value in the combo box selected right from the start, so we don't get a kind of desync between our Rust database and our QML GUI. Now I'll simply go ahead and do the same for the language as well. So now we have both a label and a combo box for our greeting and our language. And the last step here is to simply add our button that, when clicked, will call the greet function and print the result out via QML. And that's it. That's our QML GUI. This, in my opinion, is a very nice way of writing these kinds of UIs, because we simply describe what we want to achieve and not necessarily how to get there, in which order certain things need to be arranged. We just write the results of it and we're good to go. And in this case, even with a Rust-backed backend. So with our QML UI defined, we now need to figure out how to build this all, and then how to actually run the application. With CXX, we use CXX-Build. And like I said, CXX-Qt comes with CXX-Qt-build. So we will need to also add this to our build script. In our build script, we can simply get rid of the existing code, add the imports for CXX-Qt-build, and then we can start using the CXX-Qt builder, which is the main interface to building with CXX-Qt. I should note here that with version 0.7, we've stabilized much of the API, especially when it comes to the CXX-Qt bridge. We will also do our best to keep the API with CXX-Qt builder compatible. However, this will be a big focus for version 0.8, so at least the build script may still need to be slightly adjusted, and you should look up the documentation of the current version of CXX-Qt if any of this doesn't work out as it does here in the video. But for now, we can simply create a new CXX-Qt builder and then add a QML module to it. Inside our QML module, we first of all need to define the URI. This is the name of our QML module, in our case, com.kdab.tutorial. Our QML module should also come with some QML files, which is of course the QML file we just wrote. And we'll also want to add Rust files to our QML module. These Rust files are Rust files that contain CXX-Qt bridges. So this is how we tell CXX-Qt to expand the CXX-Qt bridges in these files, build the C++ equivalent, compile it into our app, and expose it as part of the QML module, which is also what enables us to use QML element. QML element only really makes sense in the context of a QML module, so always make sure that if you're using QML element, you're also exposing these Rust files via a QML module. We will then also tell our CXX-Qt builder what Qt modules we need. By default, we already include, in this case, the QML module, because we're at the Qt module for QML, as we are ourselves defining a QML module. But for compatibility with macOS, we'll also want to add the network module, which is sometimes required on certain builds of macOS. But if you don't need this, you might as well leave it out. And we can then build our application. This is now set up the build for our CXX-Qt bridges. However, our main function is still the old main function from the previous video. And of course, in this case, we want to start a Qt application. So let's go ahead and add that. Inside our main file, let's get rid of the existing code and import some more types from CXX-Qt-lib. First of all, we will need Qt GUI application because we want to have a GUI application with QML. And the second one is that we want to have a QML application engine. This is what allows us to load and run QML files. We can then simply use the new functions on these types to create instances. When we use these types through CXX-Qt-lib, we should note that because they are wrapped types from C++, we need to use them through CXX's unique pointer abstraction, which allows these Qt GUI application and the QML application engine to live on the C++ heap, but to still be accessible via CXX, or in this case, via CXX-Qt-lib. We will need to actually check, though, that these unique pointers actually include values. This is just a precaution that Rust requires, because in theory, a unique pointer that is coming straight from C++ may be null, so we need to check this. We'll also need to call asMod here to go from a unique pointer to a mutable reference to our engine. To then load something into our engine, we also need a third type from CXX-Qt-lib, which is QURL. And like with QString, we can create a QURL from a Rust standard string, and this should describe where to load our QML file from. In this case, because we've added our QML file within our CXX-Qt builder, we can access it through Qt's QRC system. This is a way of compiling files right into your application, so you can never miss deploying them with your application, and they will always be accessible. And when adding them to a QML module, they are under a standard path that is determined by the URI of your module as well as the path of the QML file itself. In our case, this path is qt/qml/com/kdab/tutorial. Note how here the periods are replaced by forward slashes, so sort of folders in this case. And then we have our QML folder, which we've added in the QML files part of our QML module. And in there is our main.qml file. And we also need to make this a reference, so Rust's borrow checking works out. And then we can access our app as well in a mutable way, and then execute our Qt application. And in case we've done everything right, should now be able to run our application. As I mentioned, CXX-Qt-lib can take quite a while to build, but the good news is once you've done that once, you shouldn't really have to rebuild lib only every once in a while when you bump your CXX-Qt application. Okay, so here I've actually made a mistake in my QML file, so let's quickly go back and fix that. Here inside my QSTR call, I've accidentally mixed up the parentheses, so they need to be on the outside, of course. Now let's try it again. We also, of course, need to make sure that our Rust type is public, as we will be exposing it to C++, it can't be a private type. Okay, there seems to be another mistake within my QML file, so let's take another look at it. In line 18, this should read anchors.fill_parent, which means that we fill the whole parent window, not just anchors fill true. And there we go. Here's our final application. We have our two options for which greeting to use. We have our three languages, and when we click read, drum roll please, we get an output by QML on the command line down here. And we can change the greeting, can change the language, and everything immediately updates. So that also shows you that, like we said with QProperties, we are able to access Rust data directly from QML and assign new values to it. And it will automatically update our backend. It's as simple as that. To summarize, with CXX-Qt, we were now able to add a QML UI to our Rust code. Based on a Rust struct, we created a new QObject class with the QObject attribute. We exposed data from the Rust struct to QML with QProperty. That data also included enums, which we exposed to QML as QEnums. And then to allow QML to call into Rust code, we used the QInvokable attribute. Finally, we combined it with QML into our very own UI. With these basic features alone, we could already build some powerful applications. But we're not done yet. In the next video, we will learn how to write models that can expose large data structures to QML, which is one of the most fundamental features that a UI backend needs to perform. Make sure to subscribe so you don't miss it. We will also link some more resources on CXX-Qt in the description that you can check out in the meantime. Bye und bis zum nächsten Mal.